Welcome to the Journey Shake Chem. I am so excited today that you're here with me to start a new topic. Yes, we are on oxidation and reduction today. Well, to start out with, we're going to do a little bit of review. So do the best you can, please, and we'll go over it in a moment. In number one, we are determining the oxidation number of the underlined element. Well, in the first one, we have a polyatomic ion. Therefore, I am going to set the whole equation equal to the overall charge of that polyatomic ion. Oxygen's charge is -2. It's following its periodic position. However, there are two oxygens, and that gives me a -4. And therefore, in this case, nitrogen is +3. Secondly, we still have a polyatomic ion. Oxygen is -2. There are 3 of them. And therefore, I have a -6 on the oxygens, and in this case, nitrogen is +5. It is very important to realize that oxygen's charge is -2. However, I have different numbers of atoms, and so the overall charge on those oxygen changes, but the actual charge on the oxygen does not. Now we have a compound, and I set compounds equal to 0. Oxygen is still -2, and there are 2 of them, which gives me a -4. And therefore, in this case, nitrogen is +4. Then we have compounds, and we have been removing the compound from, removing the polyatomic ion from the compound. And I could do it in the compound, and potassium is always +1, and therefore I know that this polyatomic ion must have a -1 charge. It is chlorite. Therefore, I have chlorite is -1. Oxygen's charge is following its periodic position, and we've done this before. -2. There are 2 of them. That gives me a -4. The overall charge of this polyatomic ion is -1, and therefore chlorine in this case is +3. Again, we have another one of the polyatomic ions, perchlorate. And oxygen has a charge of -2. There are 4 of them. That gives me a -8. The whole polyatomic ion is -1, and therefore, in this case, chlorine is +7. +3 and +7 is what we have so far. Then finally, I have chlorate. Chlorate is a polyatomic ion with a -1 charge because we have 1 potassium. Oxygen has a charge of -2. There are 3 of them, giving me a -6. The whole polyatomic ion is equal to -1, and therefore, in this case, chlorine is +5. That was some review for oxidation numbers. We're going to be using lots of oxidation numbers in our next topic, and you'll get really good at them. Now, number 2 asked, what is oxidation and reduction? Well, oxidation and reduction are reactions where one substance gains electrons and one substance loses electrons. Therefore, there is a transfer of electrons. And that's different from whatever we've done before because we always had the charges staying the same. Remember when we did oxyacids and we had to find the charge of that nonmetal? Because it was the same on the other side of the equation. The product was also the same charge of the nonmetal. They did not change their charges. Now we're learning something new, and we're going to change the charges. And when there's a transfer of electrons or a change in charge, that means that we have a redox reaction. And that's what oxidation and reduction is. And we see it all over the place. When I leave my bicycle out in the rain and it rusts, well, that's a redox reaction right there. And when we burn things, those are oxidation and reduction. When we get old, there's lots of oxidation and reduction going on in our bodies. And it's just all around us. Lots of oxidation and reduction. When we're plating gold jewelry, we're using oxidation and reduction. There's very, very many of them all around us. And I'm looking forward to learning some more about it. And I'll be right back. Oxidation and reduction reactions are balanced by what is called the half reaction method. We will take half of the equation and balance it at a time, and then we will add them back together. But first we're going to practice how to balance a half reaction. We need to learn that first and feel comfortable before we move on to put the reaction together to get a whole reaction. Well, there are two types of solution that these occur in, and they are either acidic or basic, those acidic solutions. And acidic solutions, we can only add hydrogen ions, water, and electrons. Those are the only players that are allowed to come onto the court in this game. Now, we have both oxidation and reduction going on. Well, what is that? Oxidation is losing electrons. Oxidation is losing electrons. And reduction is gaining electrons. Reduction is gaining electrons. That's an easy way to remember it. Oil rig. Oxidation is losing electrons and reduction is gaining electrons. Now there is also another little saying that some people use. I'm not as fond of it, but I'll let you know what it is. And it is Leo goes grr. Losing electrons is oxidation. Gaining electrons is reduction. Some people like that. I prefer oil rig. For me, that's what works. You can use whichever one you need to use because we need to remember that when we lose electrons, we are oxidizing. And when we are gaining electrons, we are being reduced. And also in reduction, you'll see there's a reduction of the oxidation number. It goes down. Now, we're going to balance two different reactions by the half reaction method. And I'll be right back. The first thing that we must always do when we are balancing half reactions is find the charges of all of the elements. And iodine is standing alone. It is a diatomic molecule. And anything that is by itself, standing alone, must be 0. And then obviously, my iodine here is -1. And what has happened here is that I have gone from 0 to -1. However, I must also notice something very, very important, and that is that there are 2 iodine atoms here. And I need to take care of that first. Therefore, I'm going to put a 2 in front so that I have 2 atoms of iodine on both sides of the equation. Now, when I change the charge from 0 to -1, that means that I have gained 1 electron. And we're going to do a little practice exercise to help us remember that. Now, or remember how to determine if it's gaining or if it's losing electrons. Now, we always do this for one single atom, gained 1 electron, but there are a total of 2 atoms. Therefore, I gained a total of 2 electrons. Now, the charges must be the same on both sides of the equation. I'm going to write this a little bit better for you. And I want the charges to be the same. So if I add those 2 electrons to the other side of the reaction, then I have a -2 here, and I have a -2 here, and the charges are balanced. And then we'll learn a little simple way of trying to remember which side the electrons are on, because sometimes we just don't want to think about it. We just want to add the electrons. And then that is balanced. The next one that I am going to do is H2S. And it is going to go to sulfite, the polyatomic ion. Now, there is no hydrogen over here, so I don't need to worry about the hydrogen's charge changing. It is +1 here. And sulfur is in the negative position, and therefore it is -2. Here in my polyatomic ion, oxygen is -2. There are 3 of them. That gives me a -6. The whole polyatomic ion is -2. And therefore, in the sulfite ion, sulfur is +4. Now, sulfur went from -2 to +4. It had 2 electrons. Remember, electrons are negative. It had 2 electrons. Now it's in debt by 4 electrons. Therefore, we lost a total of 6 electrons, and it is oxidized. And the first one that we did was reduced. Now, to balance this half reaction, I lost 6 electrons. Therefore, I will add my 6 electrons to the product side. Whenever we lose electrons, we add them to the product side. And a little way that I try to remember that is that losers are produced, or losers are on the right. Whichever one helps you to remember that. Losers, electrons that are lost, are placed on the product side of the half reaction. Then I need 3 oxygens to balance my number of oxygens. But I have to go back and remember I can only add these 3 players to my quart. And therefore, oxygen is only contained in the water. And therefore, I'm going to add 3 waters. This gives me 6 hydrogens here, plus 2 hydrogens is a total of 8 hydrogens on this side of the reaction. And therefore, I'm going to add my 8 hydrogen ions to balance the number of hydrogens. And then that half reaction is balanced. And when we get ready to balance a full equation, this one gains, this one loses, we could add them together, but we're not quite ready for that. That's going to come in a few days. So let's just practice trying to figure out some of the oxidation numbers in tonight's assignment. All you need to find is what changed its charge and how many electrons total were lost or gained. For example, this one gained a total of 2 electrons in this half reaction. And that's all I'm going to talk to you about today. I think that's quite enough to begin with, and you can get an idea about redox. And thanks for being here, and I can't wait to see you tomorrow. Bye.